Just the multiple choice stuff. That's the only thing on the final is the multiple choice. Yeah, no essay. So, for time's sake. So, problem number 16 on the hard copy, it says find the zeros for f of x equals x squared. By the way, I'm recording, guys, so keep that in mind. 7x plus 9. Now, when they say zeros, what they really want to know is when does the function x squared plus 7x plus 9 equals 0. Now, you can find this easily enough by just graphing that. So if I go into my graph and I go to y equals and I type in x squared plus 7x plus 9 and I hit graph, well, it looks like it crosses here and it looks like it crosses here. So it's going to be some sort of decimal value. It's not like -2. It's between -2 and -1. And over here, it's like 3, 4, 5. It's between -5 and -6. So I can plug that into the, plug that into the quadratic formula. Remember, it's written in the form ax squared plus bx plus c, just like our last example, equals 0. So that means that there is an implied 1 in front here. So that means that my a term is equal to 1. My b term, which is in front of the x, is equal to 7. My c term, which is the constant, is equal to 9. So I start over. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Plug and chug. I'm going to say x is equal to -b, which is 7, plus or minus the square root of 7 squared, plus, minus 4 times a, which is 1, times c, which is 9, all over 2 times a. Now, that will equal x equals -7 plus or minus the square root of 49 minus 36 all over 2, which is equal to -7 plus or minus the square root of, what's 49 minus 36? Isn't that just 13? Yeah. 13 all over 2. And, I mean, that's the answer right there. And you could plug that into the calculator, but your multiple choice says just do that. And when you multiply that in the calculator, you'll see it'll be between -1 and 3 and -5 and 6. The decimal approximation. Okay? Find the zeros just means where does this equal 0? Where does y equal 0? So if you say find the zeros, what they're saying is when does this thing right here equal 0? So you just plug in the 0. And once it's set up in that form, you could use a quadratic formula. Also, by the way, what is this line right here? Well, this line, the x-intercept, occurs at y equals 0. So remember I said you could solve any equation by graphing the left-hand side of the equal sign and the right-hand side of the equal sign. So that's what we did. If you look at the graph, we're looking where these two lines intersect. So you could literally do this. You could say second calc, go to intersection, or you could actually do the 0. And the problem with that is it's going to give you the decimal, and you don't have the decimal. But you could approximate. So you do the left bound, right bound. So it's -1.69. If I were to plug this into a calculator as a fraction, I would say -7 plus the square root of 13 all over 2, and that's that number. If I repeat that and I edit it and have a negative sign in the middle, or not negative sign, a subtraction, that gives me the other value. Does that make sense? So that's why that's kind of a neat thing. That's what's nice about knowing how to use the calculator is that I can double check all the work. I'm going to post that in the thing here so you guys could see. Hold on, I'm just posting this in here. So that is approximately what that is. And then if I go back to the graph and I look at the graph, you could see that that's about where it crosses. And so what we're looking at is where these two cross. Oh, grabbed the wrong pen again. So this value here is the intersection here. And this value here is this value here, which occurs right here. Does that make sense? Okay, cool. Okay, that's it. That's